Okay, so some homework on polar, and the directions here said to the rectangular coordinates of points are given, plot the point and find two sets of polar coordinates for theta between 0 and 2 pi. So negative 3, 4 is left 3, up 4, right? And for what do we need for the polar coordinates? What comes first? R and then the theta, right? So essentially, this is a 3, 4. What's the R? 5. 3, 4, 5, right? 4 squared is 16. 3 squared is 9. 16 plus 9 is 25. Square root of 25. So the R was easy. And then the angle. Now that's going to be the kicker on this particular problem. Because if it was in quadrant 1, then I could just put arctangent of 4/3, right? If I just do arctangent of 4/3, I'm going to get a negative answer. Does that make sense? Because, so I guess I could go negative 5 arctangent of negative 4/3, because that is the angle that has a tangent, right? Opposite over adjacent. The problem is, this angle, if I plug it into my calculator, will it be an angle between 0 and 2 pi? Nope, it's going to be negative, right? Arctangent negative 4/3 is some negative point.
Wait, is this on radians or degrees?
It should be in radians, yeah. This should be an easy section. Is that what you're saying?
No, he was asking how you got tangent, like what tangent?
Oh, because if this is the angle opposite over adjacent, right? But we need, so I do understand if that angle was negative 0.9 something something, right? That this angle in here would be 0.9 something something, right? So how would I get from here to here? Or from this negative one to that positive angle. If I want to go back and call it positive 5, what would I need to do to this arctangent to make the angle land right there? Add pi.
Oh, I did not do that.
How'd you know that?
Actually, because that was going to be a negative, my thought really was say pi minus that angle. So you could have said pi minus arctangent of positive 4/3. Does that make sense at all?
Wait, how is it negative on the other? How is it negative? Like how is it in the fourth quadrant?
Oh, with arc sine and arc cos, an arc tangent, the only two quadrants that we use are quadrant 1 for the positives and quadrant 4 for the negatives. And the answers will always be between negative pi over 2 and positive pi over 2. That's like by someone's definition. And so if I plug in arctangent on my calculator, it is going to, if it's a negative number, it's going to be a negative answer in this quadrant. So I had to use whatever thought process to get that to be the positive theta going from 0 over to that line. And so your thought process of just adding pi was a good idea because it took us over there, right? Let's test it. Add pi to it. .214. Does that make sense that 2 radians 1 radian is gonna be in here, 2 is gonna be here, somewhere in there. 3.14, right, is pi. So 2 radians is certainly in quadrant 2. But they told us to give 2 points. So if we want to go use the -5, but it told us we want it to be between 0 and 2 pi. So how would I get all the way around the other way to that point?
You got 2.
Add 2 pi.
Without the tangent, I mean, without the 2 pi, like just inverse tangent.
Inverse tangent of 4/3 would put us at that point, you're right. However, the directions said keep theta between 0 and 2 pi. And that one we saw in the calculator was something negative. So we had to make it positive.
Okay.
Yeah, it's, you know, not super easy. It's definitely digging deep in your pre-calc knowledge. How many of you remember? Kind of.
I remember like a plus 2 pi k. I did.
Plus 2 pi k means, yeah, you can always add 2 pi and make it end up right back where you started, right? All right. 17 was one where it says, use the angle feature to give one set of polar coordinates. I 3, -2, 1, 2, 3, down 2. My thought process is just to use an inverse trig function to get, I mean, we got 2 units there, 3. We know the hypotenuse, 3 squared 9 plus 4 is 13. Root 13 is the radius, right? And then at that point, just figuring out what the theta is. It didn't say theta had to be between 0 and 2 pi. So what could we just say? Inverse tan of -2/3. And that's my non-calculator answer. Or if we had the calculator, plug, you know, inverse tangent of -2/3. -0.588. But let's just look at the angle. There's a second this. Does that show polar? Well, look at that, rectangular to polar.
Ah,
3, comma, -2, was that it?
Yeah.
The point.
Where, 3 points, what? That's not rectangular to polar, is it?
is that the hypotenuse?
Square root of 13. Okay, so that's the hypotenuse.
The one it told me to do was math, and then,
Oh, it was math?
yeah, good at math.
I wanted to see what. Oh, you know what? Maybe we got the R was for the radius. Let's do this one, and we'll get the theta. 3, comma.
Oh, yeah.
Second
Oh,
angle,
radius.
the second
It was
axis.
second apps. It shows angle right there.
Okay, I see it.
There it is.
Wow.
Can we use a calculator on test?
Heck no.
-0.5. What?
Well, maybe, but if I'm asking for the decimal version, but you know. So what did it tell you to do, math?
Math, and then over to CPX, and then 4.
4. Okay.
I don't know what that does though. I didn't know what the plugin, maybe yeah.
Nope, that wasn't work.
Yeah, when I Googled it, that's what it said to do, and I couldn't figure it out.
But I believe they were talking about this angle, the second angle feature there, which, I mean, these other things, you can, like if I gave 34.567 degrees, this DMS turns it into degrees, minutes, and seconds, which is an old version of angles, of degrees with angles. I don't even know if anybody uses it. I know that the engineering teacher made them convert. We used to. I'm pretty sure we did it when I was in like trig,
What
but
is it? What are minutes and seconds?
it's
on
the
an
it.
angle?
Well, what's a minute and a second in terms of an hour?
60?
Yeah. So literally,
60 what on an angle? 60.
what did I made up? 34.567. If I said 34.567 degrees, then that's going to be 34 degrees, right? And then I would say 0.567 divided by 60. Not divided by times, sorry. Because there's 60 minutes in 1 degree, just like there's 60 minutes in 1 hour, right? So I would multiply that by 60. So I would get 34 degrees, 34 minutes. Then I would go 0.02 times 60 seconds. So 1.2 seconds. That's how you would write it in degrees, minutes, and seconds.
So what is that used for?
Yeah.
It is, and I don't know if it might be used in navigation, or if you think about like radar screens, they give minutes and seconds are used in latitude and longitudes, I'm pretty sure, in the
Like more
angles,
accurate.
to get more accurate readings.
Cool.
So they don't use it, 34.567. Let's do that degrees, minutes, second thing. Turn it to degrees, minutes, and seconds. Woohoo! Learn something new every day. We learned
Learn
vehemently
two new
and,
things.
yeah. All right. That's your little, I mean, if you were ever exposed to degrees, minutes, and seconds, now you at least have a frame of reference, right? 47. There's just so many topics in math that we could do. We used to do in trig, in advanced algebra and trig, we used to do proof by mathematical induction. And it's a really neat thing, but it kept us from being able to prove, like the integral formulas. All right, so in exercises 47 to 56, use a graphing utility to graph the polar equation. Find an interval for theta over which the graph is traced only once. So this one was a calculator problem, right?
Yeah.
So what mode should we be in? Yeah, radians for sure, and polar for the equations, right? So it gives you your R. Insert 2 minus. Is that it? Now, let's check for our window. The window is going from 0 to 2 pi, right? I also like to go arrow left and get that little dash with the circle so we can watch it trace it, right? that looks like the whole figure is traced in exactly what units? 0 to 2 pi, right? Now, one of the kids from Burton said, but Ms. Washington, the book said negative pi to positive pi. Well, it just starts at a different spot, right? But I have a feeling it is taking, is that pi? It is taking the 2 pi's to get it graphed, right? But if we had put in more, like let's go negative pi to 2 pi. You'll see how it just keeps going around the same spot, right? So does that make sense that it takes either from 0 to 2 pi or from negative pi to positive pi? Give me some more. Negative 2 pi to 0, would that work? I have a,
0 to 4 pi.
oh, the book said 0 to 4 pi?
On number 53.
On the next one, on 53. Yeah, so let's look at 53. Yeah, we could have gone negative 2 pi to 0. And it's going to trace around that thing. It's just going to start at a different point, but it will be completely traced around. Does that make sense? 53, the formula was R equals what? 2 cosine of what?
3 theta over 2.
By the way, if you think of the graph, the rectangular graph of this, what do we always do as use as the period? 2 pi over the k value, and the k value is 1, right? This one was weird though, because if I think of that one, 2 pi over 3 over 2 gives me 4 pi over 3. But when we put it in there, it clearly doesn't go around the whole figure in 4 pi over 3. 3 theta over 2. So if we start with our normal, like 0 to 2 pi, we do not need, I'm just doing 7s. I'm gonna leave those 10s, see what it looks like. Maybe we don't need to see it. Negative 6 to positive 6. That doesn't look complete, does it? So, you know, I was thinking 4 pi over 3. Even less of the figure, right? So 4 pi, oh, sorry, 0 to 4 pi. Hopefully you see that it did come back to to like where it started. So 0 to 4 pi, would negative 2 pi to positive 2 pi have worked? Yeah.
So how do you solve for that 4 pi? Like, how do you, is it just a guessing game? Is it like
I think it's kind of a guessing game because if I'm graphing these, I'm trying to figure out where does the outermost point come on a cosine curve? Just a normal cosine curve. Where does the highest point start? At 0, 1, right? pi over 2, it hits 0, right? Pi, it hits -1. 3 pi over 2 is back to 0, right? And but that's for regular theta, right? So we clearly start out at 0 at the 2 times 1, correct? So where is the first petal gonna hit 0? Well, when 3 theta over 2 equals pi over 2, right? So where would that land? At pi over 3? So when we get to pi over 3 is when it finally comes down and hits 0. Where is it going to go back and hit -1? Equals pi. So that would be at 2 pi over 3, right? So at 2 pi over 3, it's gone and hit the -1 times 2. Oh, goodness. I didn't need to have at least equal units, don't I? Then, literally, we can keep going. It hits 0 again when 3 pi over 2 equals pi, right? Oh, wait, did I already hit that one?
Well, so we will always have a calculator for these. It's the only way you know what the shape of it is from the graph that we got from the calculator. Because without it, how would we know which way it was turning every time?
When it hits pi is when it hits back to 0. What was your question?
Will we always have a calculator for these? 'Cause
I believe I have seen almost every polar one with calculators.
I feel like it would be really hard to do that, do every single step until it gets back.
Yeah.
Without-
So, but what's going to happen is it's going to keep going, and then when you get back, you'll realize, it doesn't match up there. So we throw in some extra petals between the other petals. Does that make sense? Like when we graphed this, wait. I want to see a little bit more, so. Well, it filled in as we went. It just kept, but it just kept forming new ones as you went around, and it didn't actually. Well, let's plug in 4 pi. 4 pi for theta. Where does that get us? 6 pi. And so it took 6 pi to get all the way around there, essentially. Strange.
You said it took 6 pi to get all the way around?
Well, after it took 4 pi, but I said 4 pi times 3 over 2, and that gave us 6 pi actually. So it's still a pretty figure, isn't it? There are real issues with this as we move into finding areas, because there's like these overlapping things that causes issues with areas. So. Does that get you going at all enough to where you can use the calculator some?